Okay, so this video is going to be about reviewing what moments are, how to calculate moments, and how to determine their signs so that you can properly set up a equilibrium equation for the sum of the moments about some point. Okay, so we look at the figure that we have here. We're just going to review what's in here so we know what we're working with. This is the figure that we're going to use to calculate our sample equation. So the first couple forces I want to mention are the ones that are color-coded. I have this A that's pointing up on the left side, and over here on the right side I have this B pointing up. These are my two unknowns which we'll need to determine. Okay. The next force that I have is this 10 that's here, and that's 4 feet from A. We've got this 5 pounds, which is 10 feet from A. We've got two moments that are sitting here as well. We've got this 7 pound-foot, which is pointing in the counterclockwise direction. And then we also have this 3 pound-foot, which is pointing in the clockwise direction. Okay, so we have all of that there. We know what all of those pieces are. Now, the first thing that we're going to do is we're going to review what a moment is. A moment is actually a force times a distance. So whenever we're calculating moments, we need to make sure that we're using a force and a distance. Okay, so we're going to go ahead and set up our equation. I'm going to go ahead and I'm going to insert a symbol here. Insert my sigma, because that's what I'm going to use to take my moments. Okay, and I'm going to use my M, okay, because I'm taking the sum of the moments about A. All right, and I'm going to go ahead and make sure that that's capitalized. And in order for equilibrium to occur, all of our moments, when they add them together, they must equal 0. So that's a condition for equilibrium. Now, when I'm calculating my moments, I like to work from left to right, just like when I'm reading a sentence or I'm reading a word. And this will allow me to make sure that I've basically compensated or used everything that I need to. So we're going to start with A and then work our way to the right-hand side. So we'll start with A. That's the moment that's the point that we're starting with. And we need to find a force and a distance for each particular item. So our force in this case is A, and our distance of A from A is 0. It's a little bit of a trick there. When you get really good at doing this, you can just ignore it. You can kind of skip it because you know it drops out. But since we're just practicing and just learning how to do this, we're going to make sure that we write it down so we know we've accounted for it. Now, moving left to right, the next thing that we're going to do is we're going to go ahead and add. Our next force is 10. And then our distance here is 4. Okay, but we have to worry about the sign for this particular moment. That's where something called the right-hand rule comes into play. Now, if I'm using the right-hand rule, I'm going to put my wrist on the point where I'm taking the moment from, which is, in this case, A. I'm going to curl my fingers in the direction that the force is pointing. Now, if I do that, I can't curl my fingers, in this case, without flipping my hand over. Whenever I flip my hand over, that means that the moment is negative. But if I can curl my fingers the way the force is pointing, then it's positive. Now, that's a little confusing, and it's kind of biased towards right-hand users. So I like to use kind of like a clock rule here. So if I put the center of my clock where I'm taking the moment from, and if you think about in math class how we count our angles, if we had the center of the clock here, and that's the origin, the 0, 0 point, and then we go in this direction, that basically means that we are counting angles in a negative sense. So anything that's going in a clockwise fashion with the clock rule is going to give us a negative value. Okay, so in this case, this 10, if I have the center of the clock here and I'm pointing down, that means I'm going in the clockwise direction and I'm going to be negative. So I'm going to put a negative sign on my moment. Moving on to the next one, my distance in this case, my force in this case is 5, and my distance is going to be 10 because I can see that in my picture. Now my sine, if I take a look at that using my clock rule, there's my center of my clock, and then I'm pointing in the counterclockwise direction. If I'm pointing in the counterclockwise direction, I'm counting angles in a positive sense. So this moment here that I'm highlighting right now is positive, so we'll leave that alone. Moving on to the next one, the next number that I have here, I have this 7. So I'm going to go ahead and put that 7 in there. Now there's no distance associated to it because it's already a moment. It is 7 pounds-feet. So we don't have to worry about any type of distance because it's already built into that number, okay? We do, however, have to worry about the sign. So if I put my center of my clock here at the A, and I look at the direction that it's counting, it's going in the counterclockwise direction, that means that that is positive. So I'll leave that alone. Moving on to the next one, we've got this 3. Okay, and again, there's no distance associated there. Sometimes there will be a distance associated to it. If there are any distances associated to any of these moments, it's just an extra piece of information that we can ignore. Okay, now the sign for this one is going to be different because if I have the center of my clock here and I'm moving in this direction, I'm moving in a clockwise fashion, that means this is going to be negative. So I have to put my minus sign there. And moving on to my last force, I've got B. That's my last force. And in this case, my distance of B from A is 22. Okay, and let's double check my sign here. If I got the center of my clock here, and I'm pointing in this direction, I'm pointing in the counterclockwise direction, that means that this is positive. So now my sum of the moments equation is complete. So the next step here, we could simplify this, and we're going to go ahead and do that to continue just to reinforce this, simplify this. So my A times 0, that drops out. I can ignore that. I'm going to go ahead and do my math here for the negative 10 times 4. I'll get a negative 40. Okay, moving on to the next term. I've got my 5 times 10, and that's positive, so I'll write the 50 down. My next term is a positive 7. The term after that is a negative 3, so I'll do plus negative 3. And then my last term here is my 22b, and that's positive, so I'll keep that as it is. Now, all of that has to add up and equal 0 in order for equilibrium to occur. So the next step in this problem, which we will not do, is we'll take this equation here, okay, and simplify it further. That way we can solve for this b value and move on in the problem. So I hope that helps you. If you need to watch it again, feel free to do so and watch it as many times as you need to.